Okay, last class in the matrix methods, stiffness matrix methods, it's truss element. Okay, truss element, truss element. So, so truss also takes only axial force. You already know it. Only axial force. So, but how it is different from the axial element? What is the problem faced in the truss element? We'll see. So, if you see axial elements, what we discussed, these are the two elements. Two elements. Axial elements. If you see, if you observe it, these are the two elements, axial elements. The displacements of the nodes is in the direction of this. Okay, the displacement of the nodes. There is no problem in connecting the one node to another node. So one element to another node, another element. But if you observe it same, if you take a truss, how it is like a truss, you already know this, this, this. This is the type of truss. This is the random example. If you see the connectivity of the truss elements, one element is in this direction, another element is in this direction, another element is in this direction. Okay, so if you see the nodes has a displacement in this direction, here this in this direction. If you observe for this element, this element node has this direction and here this direction. So if you observe the joint, one element has one element. If you consider only for the first element, we analyze the displacement in one direction. For the second element, the same node displacement got we got in another direction. How can we join both these two? How can we join these two directions? One is in some random direction, another is in some random direction. So how can we analyze a truss, a connectivity between those two elements? That we faced a problem, because this is also taken by a same axial force, but the nodes connected nodes joints we analyze in the axial element is the same direction. Previous element and next element has in same direction. The nodes are displaced, but in truss, one element has certain different direction, another element has in different direction. So for that purpose we need another dimension, not a dimensions, another observations. How it is how it is if you see, this is a global x and y direction. Take its x and y direction. So now you can observe it for each element. So suppose it is the element, it has it is so okay. for suppose for suppose for suppose this is the element. The nodal displacements are, this is I think uy and uj. You can write it ij nodes. We don't directly take the displacements of the nodes as ui and uj in the direction of the element. We don't want the displacements in the direction of the element, but we split those displacements in global x and y directions. So like, this is x displacement, this is a y displacement. Again here, this is an x direction displacement, this is a y direction displacement. If you analyze, or if you get the information from if information like x direction and y direction, so again that certain, again element, second element is in direction, so you will get x direction displacement and y direction displacement. So if you know the displacements in the global x and y directions, you can analyze. Are understood? So every node's displacements we don't take in the direction of the element. In the direction of element means this we don't take in the direction of the element. We will take the displacements of nodes in x and y directions global. Then you can easily analyze, or you can easily connect two truss elements. Are understood? So that is the problem we face. This is the solution. This is the solution. Are understood? Got the point? So that's it. Now we will see same axial element, truss also same axial element, but we won't directly take the displacement of nodes in the direction of the element. We will split those displacement of the nodes into x and y direction. Okay, so now how can we split it? How can we split it? See, so this is certain node, a random direction, a truss element, a random direction truss element. Take it, node of I, node of j. So displacement in the direction of element uy and uj, you take it. So now now put x and y direction, split the displacement ui. How can you split it? This is and this is, that's it now. U1, I think U2. So here I also split it. This is U3 and this is U4. Got the point? Otherwise I will write something. So this is UI, this is UJ. Okay, UJ split into the x and y direction. Uy split into the x and y direction. That is called U1, U2, U3, U4. So how can you split it? How can you write it? So it has a rotation, it has an angle making with x direction is theta. This is also theta. Okay, this both are same. Okay, linear element. Split it. So how can you write it? U1, U1 you can write Uy cos theta, U2 Uy sin theta. Okay, same U3 Uj cos theta, U4 Uj sin theta. Got the idea? So, simple way. So now you can write in matrix form. Now you can write matrix form. U1, U2, U3, U4, U4. You can write cos theta 0, sin theta 0, 0, cos theta 0, sin theta, Ui, Uj. Set it. See, U1 is cos theta into Ui, 0 into Uj. U2 sin theta into Ui, 0 into Uj. Got the idea? So these are the local displacements, not a local it's okay, local axial displacements in the direction of element, these are the displacements in global. You can ask global x and y direction, so these are the local displacements in the direction of the element displacements. These are the global x and y direction displacements. Are understood? So what is this, sir? What is this? This is, you can call it as a transformation matrix. So transforms the local displacements to the global displacements. Are understood? Transform local displacements to the global displacements is called transformation matrix. This is a transformation matrix. And also you can you can write same and you can observe it. Forces also you can split it. For the displacement in this direction you can get it the same Pi, same Pj. Force is in the direction of displacement only, na? So you can split the force also in x and y direction. This is P1 direction force, this is P2 direction, this is P3 direction force, this is P4 direction displacement, P4 direction. Understood? So same again, same split equations. Force is also split into the, not in the direction of the element. Force also we can split into the x and y direction. So you can write same as a P1, P2, P3, P4, not Pi, Pj. Okay, not Pi and Pj. Nodes are I and J. So same cos theta 0, sin theta 0, 0 cos theta, 0 sin theta. You can write it. So Pi and Pj. You got the point? Same, this is a transformation matrix. You can write it like, yes, you can write it. Got the idea? So that's it. So now we can see, from the local displacements to the global displacement, this is a transformation matrix. From the global, how can you get the local displacements? So for the final equations, you have only u1, u2, u3, u4, p1, p2, p3, 4. Finally you achieve only u1, u2, u3, u4. So finally you got these values. From these values, how can you get these local displacements, or why we need a local displacements? We need a local displacements because for the stress and strains in the element by only local displacements, na? So this is the element. What is the stress? What is the strain? Strain be the displacement in the element, in the direction. It will go, maybe it will stretch here. You have to find out the local displacement, then only you can get the stress, strain, something. So from the global, how can you achieve a local? So just a place inverse of this. You can put a try inverse. So like I will write u1, u2, u3, u4 as a transformation matrix, and ui and uj. Put a inverse transformation matrix inverse. So what is this? This is value I. So this is the value. Okay, so what is uy and uj is equal to the inverse of the transformation matrix u1, u2, u3, u4. Okay, that's it. So what is the inverse of this matrix? Sir, this is not a square matrix. How can you get the inverse? That is the question mark, no? So no need at all. Just see these equations. You can write down uy equal to, how can you write in u1? Just see it is u. Just see it is uy. You can write it. See, u1 cos theta plus u2 sin theta. Can you write it? Sir, just explain. See, u1 is what? u1 is ui cos theta. And cos theta. u2 is ui sin theta. Multiply with sin theta. What is that? ui cos square theta, ui sin square theta. What you will get? ui outside, cos square plus sin square is 1. So ui is equal to ui. So you can write ui as this much. So I will write here. So ui from the global displacements to the local displacements, ui equal to u1 cos theta, u2 sin theta. Same thing, uj. How can you write it? uj u3 cos theta plus u4 sin theta. You can write it. No need to find out the inverse of the matrix. It is not a square matrix, so you can't find it. Okay, so now you can find out you can write this equation to the equations matrix form. ui uj is equal to see, how can you write it? Cos theta sin theta 0 0 0 0 cos theta sin theta u1 u2 u3 u4. Same equations. Proceed. Uy equal to cos theta u1 sin theta u2 0 0. Uj equal to 0 into u1 0 into u2 cos theta u3 sin theta u4. Write it. So that's it. That's it. Or observe it. Observe it. These two. So this is exactly this transformation matrix inverse. Got the point? So you don't need to find out the inverse of the transformation matrix by the matrix equations. You can't find it, but by the simple equations you can get it. This is the inverse of the transformation matrix. Okay, got the idea? So now remove it. Now come to the topic. Okay, now comes to the topic. What we know by the axial element uy and uj for the single element a e by l 1 minus 1 minus 1 1, sorry, pi and pj uy and uz. This you know by the axial element in the direction displacements in the direction of the element. So we will convert this matrix equation into the global. So how can you global? So what is the pi pj? So local element forces. So we will split into the global. How can you write it? Same uy uj equal to how can I write it? uy uj how can you write it? So see what is uy uj. How can I write it? Inverse of the transverse. So inverse of the transformation matrix p1 p2 p3 and p4. Can you write it? Same uy is equal to the transformation matrix inverse and global elements. So same thing here also same ae by l, this unit matrix 1 minus 1 minus 1 1, you can write it. Here also ui is you can write it. How can you write it? Inverse of the transformation matrix u1 u2 u3 u4. Can you write it? Now apply or multiply with transformation matrix both sides. Now multiply the transformation matrix both sides at the left side. Transformation matrix here also you can multiply with the transformation matrix. What will happen? These are the one matrix, transformation matrix and inverse. It will goes to I vector, unit vector. Okay, unit vector. So this is unit vector, you can delete it. So now ae by l is a constant, come to outside. So what is that value? p1 p2 p3 and p4 is equal to what? ae by l, this is outside, transformation matrix 1 minus 1 minus 1 1, and transformation inverse u1 u2 u3 and u4. That's it. This is the stiffness matrix. Are understood? Force P equal to stiffness and displacement. This is the now global stiffness matrix, not a global, it's in xy direction stiffness matrix. This is the stiffness, not ae by l into 1 1 1. So these are the force and these are the displacements. Okay, now this is the exactly this is the stiffness. This is the stiffness matrix. Can you find out the stiffness matrix? Just multiply it. So understood? So T matrix, what are the size? T matrix, what are the size? 4 into 2. Understood? 4 into 2. So this is 4 into 2. This is 2 into 2. This is inverse 2 into 4 rows into columns. Okay, 4 into 4. What will get? 4 into 4 will get it. So write down. So T matrix, what is the transformation matrix? Multiply AE by L just outside, AE by L outside. T is what? So I will write cos as a C and sin as a S. Okay, no need to write again. C 0 S 0 0 C 0 S. 1 minus 1 minus 1 1. So C yes, okay, C S 0 0 0 0 C S. Multiply it. Can you multiply it? Easily multiply. Okay, easily multiply. What you will get is, what you will get, you can try to multiply it, and what you will get, C square CS minus C square minus CS CS S square minus CS minus S square minus C square minus CS C square CS minus CS minus S square CS S square. That's, you will get it. C means cos theta, S means sin theta. Okay, this is, you will get AE by L. So P1, P2, P3 and P4, so is equal to U1, U2, U3, U4. This is now a stiffness matrix. Understood? This is now a stiffness. K U is equal to P. Got the idea? So this is for one element. One element has a local displacements I and J. We will split into the matrix X and Y direction, P1, P2 and P3, P4. Split into this, split forces and displacements also both we split in, and we write a new stiffness matrix. New stiffness matrix for that element. This is the new stiffness matrix. Very simple here. Okay, very simple. Okay, so again for the second element. Okay, for the second element also same thing, maybe different A, E, L. So you can add at the common joint. Okay, so something like one element is this, second element is this. So it has 1 2 3 4. It has again 3 4 5 6. You can add 3 4 equations. What we did as a what we did for the beam element, same you can add it. That's it. Got the point? Got the idea? That's it. Simple. First element, second element. So how many elements are there? You can join those. You can solve it. It will take care by the system. Okay. We will see very small problem, because so many elements are there in a truss, in real truss. You can't try to get n into n number of stiffness matrix. You can't get, and you can't solve by hand. Mostly we will solve when the two elements are met by hand. Okay, so we will see the problem. You can get the idea. Okay, that's it. One problem sufficient. So what is the transformation matrix? What is the inverse of the transformation matrix? What is the useful of the transformation matrix? What is the purpose of the transformation matrix? Axial element to the truss element. Truss element, what is the problem faced by me or ours? How can you solve it? What is the purpose of the transformation matrix? This is the only question someone asks. And otherwise, this is the proof. Derivation of the stiffness matrix for the truss element. Okay, only two questions. One is a 2 marks question, what is the purpose of the transformation matrix. Second, derive the stiffness matrix for the truss element. Okay, two questions, simple way. Once you can solve it, you can get it. Just to only split in x direction, y direction, nothing more than this. Okay, so that's it. We will see the problem. 500 mm. This is also 500 mm. This is 400 mm. So you already know this is 300 mm. Okay, this is 300 mm. So the force applied, these are the two truss elements, not a beam. Or I understood, not a beam. So 12 kilonewton force is applied. Analyze the analyze the truss and find the stresses in the element. Find the stresses in the elements also. So the given is area of each element is 250 or 200 mm square. Young's modulus is 70 GPa. GPa means what? 10 power 9 Newton per meter square. Okay, you can convert it. So that's it. Now I can assign it A element, A, B, C. This is the first element, this is the second element. Okay, solution you can see, observe it for the first element. Okay, for the first element AB, what is the theta? Theta means what? Theta means C. What is the theta? What is the theta? The element makes angle with respect to the horizontal. What is that value? 0. Okay, so 0, theta is 0. That's why cos theta is 1, sin theta is 0. Okay, for the first element. So directly write. I will show you P1. This is P2, this is P1. Understood? This is P3, this is P4. Final forces. And then again this is a P5, this is a P6. 6 by 6 matrix will get it. First element is 4 by 4, second element is 4 by 4. You can add it those two, you will get 6 by 6. So the displacement is also same direction. P1 direction, it's a U1, U2, U3, U4, U5, U6. So first I will write for the first element. See, this is the stiffness matrix. Understood? So first element P1, P2, P3, P4, AE by L. AE by L is same for the two elements because length is same, area is same, area is same, Young's modulus is same. So no need at all. See, C square means cos square theta is 1. Cos theta is 1, sin theta is 0. Wherever sin is there, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. What you will get? 1, 0, minus 1, 0, 0, 0, 0, 0, minus 1, 0, 1, 0, 0, 0, 0, 0. U1, U2, U3, U4. Can you observe it? 1 minus 1 minus 1 1. What it? Because it is in this direction, it has only U1 and U3 only, na? There is no U2, there is no U4, just local. Okay, directly we already know 1 minus 1 minus 1 1, U1 U3, P1 P3. That's it, na? That's it. So this is for a first element. So now you can write it as second element BC. What is the theta? What is theta? Theta with respect to x direction. Okay, this is the theta. Are understood? This is theta, not this. What is this value? Tan inverse of 300 by 400. Get it? What is that value? That value is 36.8 degrees. 38.6. What is this value? This value is 360 minus 36.8. Okay, so I will write cos theta. 360 minus 36.8 degrees. So what is the value? No need at all. See, it is, what is the cos theta? Cos of 360 minus is a plus. Cos theta is what? What is the value of cos theta? Cos theta is what? 3 by 5. See, 4 by 5. Cos theta is 4 by 5. That's it now. 400 by 500. Cos theta is 400 by 5. What is the sin theta? What is sin theta? Sin theta is 360 minus, it's negative, minus 3 by 5. Okay, those are the values. No need at all the angle. 360 minus. 360 minus is cos theta, sin theta is sin theta only. Doesn't change it. You already know it. Okay, write down the matrix equation. So you can write it cos square and sin square, cs minus cs, multiply with those values 3 by 4 and 4 by 5. See, 3 by 5 and 5 by, see, 4 by 5. 3 by 5, 4 by 5. Multiply it and you can write the equation. You can write the equation P3, P4, P5 and P6. AE by L again, C square, cos square. What is that value? 0.64 minus 0.48 minus 0.64, 0.48 minus 0.48, 0.36, 0.48 minus 0.36 minus 0.64, 0.48, 0.48, 0.64 minus 0.48. So this is 0.36, 0.36 minus 0.48, 0.36. C square and cos square. One thing you have observed, the stiffness matrix of the transformation, the stiffness matrix of the truss element also is a symmetric matrix. Also it is a symmetric matrix, and also the diagonal elements are compulsory a positive values. Same properties which are discussed in the stiffness matrix for the beam element and axial element. It is also a same thing. It is also a symmetric matrix. Diagonal elements are positive. A square matrix. Understood? So that's it. That's the idea. Okay. Minus 0.26. Okay. So U3, U4, U5, U6. So second element. So now you can add. Now you can join those two at the joint. Write down the global matrix. So this has a P3, this has a P3, this has a P4, this has a P4. You can join those two. How can you join? You already joined by the beam element. Okay, you already joined in the beam element. Just join. So this from this it can add it. Understood? That's it now. From this you can add it as same beam. U3, U4, here also U3, U4, here also U3, U4, here also U3, U4, P3, minus 1 into U1, 0 into U2, 1 into U3, here 0.64 into U3, 0 into U4, here minus 0.48 into U4, and 0.64 into U5, 0.48 into U6. Just add it and write it. Add it and write it. I will write here P1, P2, P3, P4, P5, P6, 1, 0, 1, minus 1, 0, 0, 0. Here it's 0, 0, 0, 0, and 0, 0. Third, minus 1, 0, 1. Here you can add. I will write later. 1, 0. Here P4, 0, 0, 0, 0. Now we can add this value. 1 plus 0.64 minus 0.48 minus 0.64, 0.48 minus 0.48 plus 0.36, 0.48 minus 0.36, see 0.64, 0.48, 0.64, 0.48, 0.48 minus 0.36 minus 0.48, 0.36. Here 0, 0, 0, 0. That's it. U1, U2, U3, U4, U5, U6. That's it. That's it. Peak. And also one thing is missed. What is that miss? AE by L. AE by L for both elements has same value. That's why. Okay. AE by L is missing. So now you can apply a boundary conditions. What is the boundary conditions? Now you can see U1, U2 is 0. U1 is 0, U2 is 0 because it's a hinge joint, not a roller hinge. And here also hinge. U5, U6 also zeros. Absolute. So that's it. U1 0, U2 0, U5 0, U6 0. And again, see, these are the displacements are restrained, then forces will develop. For P3 and P4, see here, P3 0 value. There is no force in the horizontal direction. P4 as 12 kilonewtons is there, but opposite direction. We take an upwards, but it is downwards. So boundary conditions, P3 is 0, P4 is minus 12k, minus 12 kilonewtons. That's it. What is the AE by L value? Check it is AE by L value is, AE by L value is 28 into 10 cube, 28 kilonewton value, 28 into 10 cube. So I will write it. I will write those two equations, only P3, P4 equations. P3 is 0, it's minus 12 into 10 cube. So once again, if you see U1 0, U2 0, U5, U6 0, so you can strike out this. You can strike out. You can strike out, okay? Only these two, because minus 1 into 0, 0 into U2, only this value U3, this value U4, this value into U5, this value into U6, U6 0, these are all 0 now. No need to these strikeout equations, so I will remove those strikeouts because these are the hard way to remember. Okay, so write it. What is that value? AE by L, AE by L, AE by L 1.64 minus 0.48, so minus 0.48, 0.36 is equal to the U3, U4. Okay, two equations, two unknowns. What is this value? This value is 28 into 10 cube Newton per mm. Okay, these are the Newton, those are the Newton per mm, those are the value. Solve it. Solve it. Two equations, two unknowns. Solve it and you will get U3 is minus 0.57 mm, U4 is minus 1.95 mm. That's it. See, u3 and u4. So now you can observe it. What is that means? U3 means that this node this node may reach this value. This is a u this is a u4, this is a u3. Understood? Maybe previous it has here, now here. So this is the u3, this is the u4. This is the nodal displacement, not nodal displacement, node displacement. That's this is a u3 direction, this is a u4 direction. But you can observe it, not sorry, it has something problem, something. U3 is minus, na? Minus means what? Minus means this direction. Minus means this direction. U4 also minus means this direction. Maybe that means the node reached here. I understood. So previously here, now here, U3 is in this direction, it moves. U4 also downward direction, this direction. Downwards on left side. Okay. So this is the nodal displacement. Maybe here it will reach here. Okay. That's it. That's it. Both are the negative you will get. Now you can now you can solve P1, P2, P3. Now observe it. What is P2? Everything is zero, na? Everything is zero. This is zero. Everything is zero. The elements are all zero. P1 is, you will get, is 15.96. 15.96 kilonewtons positive value, because see it is a minus 1 u3, only those two. 0 into u4. U3 is negative value, na? U3 negative value, negative positive, 15.6 kilonewtons. Now you can, no need to kind of find out the P5 and P6. I will show you here. So what is P1? P1 is, what you will get? P1 you will get 15.96. P2 is 0. P2 is 0. Okay. So P2 is 0. This is 15 point. Here you will get 15.96 kilonewtons. P2 is 0. Vertical reaction is, there is no vertical reaction. So automatically this 12 will get its here. It's the 12. P6 you will get 12. Okay, P6 you will get 12. So horizontal forces also should be balanced. So P5 also you will get 15.96. That's it, na? Balance it, na? So no need to find out the P5 and P6. Okay, so those are the values, you will get it. I will write P1 15.96, P2 is 0. So P3, P4 you already know, these are the reactions. P5 you will get minus 15.6, P6 you will get 12. These are the global forces, these are the global displacements, but you have to find out the stress in the element. For the stress in the element, you have to find out the displacements of the local displacements. If it is the if it is the truss element, for the stress in the element is displacement in the elements. What is the displacement in the elements? If it is ui, it is uj. What is the displacement? Compulsory uj minus ui is the displacement. Are understood? Not local, see, not global. By global we can't. So uj minus ui is the displacement in the element. Divided by L, you will get strain. Multiply with Young's modulus, you will get stress in that element. So you need exactly the displacements, local displacements, or displacements in the direction of the elements. Are understood? In the direction of the elements. So for that purpose, first element, for the first element, so you already know u1, u2, u3, u4. Okay, u1, u2, u3, u4, you know it, but you want ui and uj. Understood? For the first element, ab, write it, ui and uj. How can you find it? You already know inverse of the transformation matrix, from the global to the local. So what is that value? C S 0 0 0 0 C S U1 U2 U3 U4. By this global you can get the local. This is inverse of the transfer. Get it there? So for that purpose I derived previously. Finally you will get only this global displacements, but you need a local displacement for the stress or strain uy and uj. Are understood? Uy and uj of any element. So you already know it. This is 0, this is 0, this is minus 0.57, this is minus 1.95. For the cos, for the first element is cos is 1, for the second sine is 0. This is 1, this is 0. Okay, what is uy and uj? Uy and uj, see directly, 1 into 0, 1 into uy is 0. You already know it. Okay. Uy is uy uj for the first element. Uy is 0 because see observe it. For the first element there is no displacement here. There is no displacement here. Are understood? Only displacement in the here only. Uy and uj. You can take it. Only uj is there. There is no uy. Okay. So you got the idea? So 1 into u3 minus 0.57. Okay, 1 into minus 0.57. So minus 0.57 only. So these are the displacements. What is the stress? Stress uj minus uy divided by length of that element. This is a strain into Young's modulus. Length value is 500. This uj value is 0.57. Otherwise you can write in a matrix methods. We already wrote in like minus 1 1 minus 1 1 uy uj e by l. We write in Excel. No need to write. This is show off. Okay, so directly you can write it. What is that value? You will get minus 72.8 Newton per mm square. That is the stress in the first element. This is the strain. You want to strain. This is the strain. For the second element also see. For the second element BC also. So same UI and UJ. CS 0 0 0 0 CS U3 U4 U5 U6. That's the here also U50 U60. Only U3 minus 0.57, U4 minus 1.95. But here C cos value is 3 by 4, 3 by 5. Sine value is cos value is what is it? 4 by 5. Sine value 3 by 5. Okay. Cos value is 4 by 5. Sine value minus 3 by 5. 4 by 5 minus 3 by 5. Here also see uj is 0 because these two multiply with u5 and u6. You already know. Here there is no displacement of the child. Only you will get ui for the element of BC. Okay, only displacement here only. Okay, so what is that value? I don't want to write. It's already lengthy problem. So directly stress you can find out what is here is 0. What is that value? You can find out. Stress is uj minus uy length into Young's modulus. I will write it's a 0.99. So length is 500. This is 0, this is 0.99 Young's modulus. This is the value of strain into Young's stress. 0.99 divided by 100 into Young's modulus. You will get it nearly 100. Okay, nearly 100. That is the stress in the element. Got the idea? So this is the way to solve a problem in a truss. Only problem I will give in the examination. Same problem, I will change the load. Try to do. Okay, try to do. I will change the load value. That's it. Okay. I will change the load value. So that's it. That's the close of the truss element. You can solve 2-3 problems again for the different cases, but it's going to be lengthy, so that's why I will stop here. You can check 1-2-3 problems in the textbooks. Okay, so that's it. Once again, axial element, a truss also axial elements, but the displacements in the direction of the elements are only we get from the axial element. So for the truss, two elements are two different directions. We resolve the displacements and forces into some x and y directions. For the resolution, we need a transformation matrix, that is called a transformation matrix. Based on the transformation matrix, we write the global matrix equation: force, stiffness, and displacements in the global directions. So for that, we will get a new stiffness matrix for the truss element. Based on that, we will solve the problems. But finally, we will get only the global displacements, global x and y direction displacements. For the find out of the stress, we need a local displacements. From the global to the local, we need a inverse of the transformation matrix. So we know what is the inverse of the transformation matrix. Based on these equations, you can solve the problems of truss element. Okay, I hope you clear. It's the end of the syllabus. Close it.